Okay, let's dive into this because a really fundamental shift is happening in how we build AI. The old rulebook, the one that's powered machine learning for decades, it's pretty much being torn up. And it all starts with a simple and, yeah, slightly weird problem.
Yep, you heard that right. Just imagine, it's 2015, and you're a machine learning engineer. Your mission is to build a model that can detect an exposed butt in a picture. It sounds kind of silly, I know, but trust me, this simple task is going to help us unpack a massive change in the world of AI.
So what we're going to do is look at this one problem, but in two totally different eras. By comparing how we tackle it back in 2015 versus how we have to tackle it today, we're going to see exactly why the old ways are breaking down and what the new AI playbook really looks like.
And this contrast is everything. In 2015, this was a piece of cake, a straightforward, almost solved problem for machine learning. Fast forward to 2023, and that same basic problem has morphed into something incredibly nuanced, complex, and just confusing, even for our most powerful models.
Back then, this was the golden age for a task like this. The rules were super simple, almost mathematical. It literally came down to measuring the percentage of, the whole process was completely siloed. You had the policy team in DC making the rules and the engineering team in San Francisco building the model. They basically never even had to talk to each other. The data got labeled, the model got trained, and boom, 92% precision, 98% recall. A huge success.
That clean, efficient, successful process, it worked perfectly for its time. But as we started asking AI to do more sophisticated things, that same method was about to run headfirst into a brick wall.
And now, the game has completely changed. The request isn't just to spot a butt, it's to build a context-aware model. All of a sudden, we're not talking about simple geometry. The model has to understand these deeply human abstract ideas like sexually suggestive posing, or sexual context, or even artistic intent. So what happens? The model's performance just craters. You're stuck, hard stuck at 85% accuracy. And it doesn't matter what you do. No amount of prompt engineering, model tuning, none of the usual tricks can get it any higher. That's when your data science spidey sense starts tingling. Something is fundamentally wrong here. This is the million-dollar question, right? The model is way more powerful. The computers are way faster. So how did the results get worse? Well, it turns out the problem isn't the model's intelligence. It's the entire method we're using to teach it. And the core issue, the thing at the heart of all of this, is our old belief in perfect data. For these new, complex, subjective tasks, the classic machine learning process, which is built on that idea, is just crumbling. The whole concept of a clean, reliable dataset to train and test on is basically becoming a myth. So this is the bedrock of machine learning 101, the train-test split. You show the model a bunch of examples with the answers, that's your training set. Then you grade it on a bunch of stuff it's never seen before, the blind test set. This is supposed to prove it actually learned the concept. But for modern AI tackling these messy human tasks, this whole process is breaking down. And here is exactly where it all falls apart. First, the rules themselves are fuzzy. I mean, what one person calls artistic, someone else calls suggestive. Even the experts who write the policy can argue for an hour over one picture. This leads to huge error rates. We're talking 15 to 30% in the very golden data we're using to judge the model. And here's the real kicker. The AI is so good, so meticulous, it often sees details the human experts miss, and it correctly flags images that were labeled wrong in the first place. And this is the fatal flaw. To figure out why your model is stuck at 85%, you have to look at the test data. You have to check those examples where it got something wrong. But the moment you look and realize, oh, wait, the label was wrong, not the model, you've just contaminated your blind test. The entire scientific method falls apart. So, if the old way is broken, what do? We need a new playbook. And this isn't just some small update. It's a completely different way of thinking about how we build and, more importantly, how we evaluate these intelligent systems. This right here sums up the entire shift perfectly. The old goal was all about quantity. Just get more data, feed the model thousands and thousands of examples, and just hope it figures out the pattern. The new goal is all about quality and clarity. Forget the massive data sets. Instead, let's give the AI a set of crystal clear rules written in plain, natural language. So the new process is this tight, collaborative loop. First, the policy experts define the rules. Then the engineer translates those rules into a prompt for the model. Then, and this is the crucial part, the experts review the model's output, not just some pre-labeled data. They find all the weird edge cases and ambiguities, and they use that knowledge to refine the rules. Then the cycle starts all over again. That old wall between policy and engineering, it's gone. And this quote just absolutely nails it. The hardest parts, the most important work, is no longer about raw computing power, about heating up GPUs. It's about getting humans, the engineers and the subject matter experts, to align on what the rules actually are and what they really mean. The real work has become human-centric. Okay, so let's zoom out here for a second. This isn't just about content moderation or that one-but model. This big shift, this move away from just training a model on data to truly aligning it with human intent, well, it has massive implications for almost every industry out there. So why does this matter to you? Because this new playbook is pretty much the future for automating any kind of complex knowledge work. Think about it. Analyzing legal documents, checking sales calls for compliance, enforcing any complicated set of business rules. The path to getting that stuff automated reliably isn't just more data. It's this human-in-the-loop alignment process. Now, let's be really clear. This is not easy. It's an arduous, slow, iterative process that demands constant human collaboration. But it's also the only path we have right now to build AI systems that are truly reliable and can actually handle the messy ambiguity of the real world. And that really brings us to the final, critical question. We've just seen the incredible amount of human effort it takes to get a model aligned on just one complex task. It really makes you wonder, what will it actually take to get past all this and build an AI that can simply know what you mean? That's the next frontier.